Hello and welcome to this revision session for GCSE Combined Science Physics Paper 2, focusing on the topics for the 2022 examination. So in today's revision session we're going to look at how you can answer examination questions on GCSE Combined Science Physics Paper 2 for those 2022 exam topics. So if we've been successful and we've learnt in today's lesson, we should be able to answer GCSE examination style questions. You should be able to assess your own understanding on GCSE physics and finally understand what topics you need to improve upon for GCSE Combined Science Physics. So how should you carry out this particular revision session? Well, when you're completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this left hand side section write down your working out and answers to the questions in the revision session. When you're doing this, make sure you write out in full sentences and show your full working out, whilst on the right hand side write down any pieces of information which you find useful or any hints and tips on answering questions from this revision session, and at the end of the revision session write up these notes into a revision sheet for you to use independently. So let's have a look at a few questions which will be on topics which will be on the examination in 2022. So the first thing is we're going to look at the topic of forces. So this first question says, figure 8 shows a girl bowling a ball along a 10-pin bowling lane. The girl is trying to knock down the 10 pins at the end of the bowling lane. Velocity is a vector quantity, speed is a scalar quantity. Describe what is meant by a vector quantity and a scalar quantity. Then the bowling lane is horizontal. Explain why the bowling ball decelerates as it travels along the lane. So pause the video now, then unpause the video when you want to go through your answer. Right, it's extremely important you know the definition of a vector and of a scalar. So a vector is a quantity which has a magnitude, a number, and a direction, while a scalar quantity has only a magnitude. Now in the second question, it's telling us that the bowling ball is decelerating as it travels down a lane. Now it's important to note that you are aware that deceleration and acceleration is only caused by a resultant force. Now because it's decelerating, it's indicating that the resultant force is in the opposite direction to the motion of the object. So therefore this resultant force must be a resistive force, such as air resistance or friction. In our next question, it says figure 9 shows the bowling ball hitting one of the pins. Firstly, write down the equation that links mass, momentum and velocity. Then secondly, the bowling ball has a velocity of 5 meters per second when it hits the pin. The momentum of the bowling ball is 26 kilogram meters per second. Calculate the mass of the bowling ball. So pause the video now, then unpause the video when you want to go through your answer. Right, this first question will not be on the 2022 examination because they're going to give you all of the equations in the back of your equation book. So the equation is momentum is equal to mass times by velocity. Now for the second question, it's important you can use this equation. Now in any calculation, the first mark you should always do is substitute the values from the question into your equation. So you would say 26 is equal to m times by 5. It's very important to write that down first on your first line of your answer to get that first mark of the question. Then rearrange that to make m the subject as shown in the mark scheme here. Then write your final answer down, which is 5.2 kilograms. The next question says, explain why the bowling ball slows down when it hits the pins. You should use ideas about momentum in your answer. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important that because the question says use your ideas about momentum in your answer, you don't talk about forces, you don't talk about energy, which is valid in this situation, but only talk about momentum because that's what the question's asking about. So it's a collision between the bowling ball and the pin. Now the first thing you've got to remember is that momentum is always conserved in a collision. Now that means that in the individual objects in the system, they can change the momentum, but the system as a total stays the same before and after the collision. So because the bowling ball is slowing down, and we know momentum is mass times by velocity, we know its momentum must be getting lower because its velocity is getting lower, and because the pin now has a higher velocity because it was stationary and now it's moving, its momentum must be going up. So the momentum of the pin increases whilst the momentum of the ball decreases at the same point. The next question says, Figure 9 shows a child climbing on a wall. There's a crash mat at the bottom of the wall. The child jumps off the climbing wall and lands on the crash mat. The momentum of the child just before landing is 160 kilogram meters per second. Calculate the velocity of the child on the landing mat, where the mass of the child is 50 kilograms. Give you the unit. So pause the video now, then unpause the video when you want to go through your answer. Right, the first thing you need to do is go to your equation sheet and find the right equation, which is momentum is equal to mass times by velocity. Now, like we said before, the first step is then substituting your values into your equation. So 160 equals 50 times by v, then rearrange it, make v the subject, work your answer out, 3.2. What's the unit for velocity? It's meters per second, so it's 3.2 meters per second. The next question says, a student ran a 100 meters race. Figure 11 shows the distance time graph for the student. The student reached a constant speed at 4.4 seconds. Determine the constant speed of the student after 4.4 seconds. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important that you should know how to work out speed from a distance time graph. So for a distance time graph, the speed of the object is the gradient of the line. So what you should be doing is after 4.4 seconds, you draw a gradient triangle onto your line of best fit. You then work out the gradient of the line by doing the change in y over the change in x. Now it's very important that you do draw in your gradient triangle, and it's very important you show you're working out, and then you get your answer to be about 9.5 meters per second. The next question says, as the speed of the student increased, the air resistance acting on the student increased. Explain why the student reached a constant speed. Use your ideas about forces in your answer. So pause the video now, then unpause the video when you want to go through your answer. Once again, as mentioned in the question, you've got to talk about forces, not energy, not momentum. Now, the next thing, which is extremely important, is to remember that a resultant force on an object causes acceleration. That's Newton's first law of motion. So if it's at a constant speed, there's no acceleration, so there's no resultant or overall force on the object. So you've got to think about the situation where that becomes the context. So you would say, firstly, air resistance acts in the opposite direction to the forward force. It's always really important to mention that air resistance and friction act in the opposite direction to movement. So that's the first thing you would say. You would then say the air resistance increases as the speed increases until the air resistance is the same size as the forward force. So our force forward is equal to the size of our force backward, so we have no resultant force. The next question says, the mean braking force on a car is 7,200 newtons. The car has a mass of 1,600 kilograms. Calculate the deceleration of the car. So pause the video now, then unpause the video when you want to go through your answer. Right, so once again, it's very important to write out the equation from the equation book given to you in your exam. So you would have seen that force is equal to mass times by acceleration. So once again, we select the values from our question and pop them into our equation. So we say 7,200 is equal to 1,600 times by A. We then rearrange the equation and make A the subject. We then work our answer out to be 4.5 meters per second squared. Now you might say, why is this not a minus value? Because it's decelerating, so it's slowing down. Well, you don't need to write the negative value because it already says it's a deceleration, so you already know it's getting smaller. So we're now going to look at the topic of waves. So the first question says, ultraviolet is a type of electromagnetic wave. Give one use of ultraviolet. And then an ultraviolet wave has a wavelength of 300 nanometers, which the following is equal to 300 nanometers. So pause the video now, then unpause the video when you want to go through your answer. Right, so what's our answer going to be in this particular situation? Well, the first thing you've got to be aware of is what's our different uses of all the parts of the electromagnetic spectrum. So you should know for ultraviolet light that the most common ones are for tanning beds and for energy efficient lamps. Other examples you could use, which are perfectly valid, are security code, detecting forged money, killing microbes, attracting insects, sterilizing surgical equipment, causing the body to produce vitamin D, increasing how quickly plants grow, and water purification. But I mean, the two major ones you've got to be aware of are the idea of like tannin beds and energy efficient lamps. Now the next question is asking you to basically work out what we mean by nanometers. Now nano means by 10 to the minus 9. So our answer is actually not 300 nanometers, it's 300 times 10 to the minus 9. But that's not actually a standard form, because standard form needs to be between 0 and 9.9. So actually 300 then becomes 3, but because we've increased it by 2 zeros, because we've got rid of the 300, it's now 10 to the minus 7. So our answer will be 3 times 10 to the minus 7 meters. Our next question says, table 1 gives the wavelength of an ultraviolet wave and 3 other electromagnetic waves. Draw one line from each wave to the name of the wave. So pause the video now, then unpause the video when you want to go through your answer. Right, whilst you don't need to memorise the wavelengths of the different parts of the electromagnetic spectrum, what you do need to do is remember and memorise the order in which they go from the longest wavelength to the shortest wavelength. Now how I always remember it is the longer the wavelength, the less dangerous the wave is. So we look on here and we say that we've got wave E, we've got wave F, and we've got wave G. So what we know is that wave E is going to be an extremely short wavelength, which is going to be X-rays because they're very high frequency. Wave F is going to be visible light because it's 600 nanometers, and it's very important you remember that 600 nanometers is a visible light. And then finally wave G is going to be infrared because it's actually going to be the longest wavelength there, which is infrared. The next question says, Figure 6 shows an X-ray image of a broken leg. Give one precaution that should be taken by a hospital worker when using X-rays. Then secondly, explain how X-rays are able to produce an image of bones. So pause the video now, then unpause the video when you want to go through your answer. Right, so it's very important that you should understand the precautions that need to be taken when you're dealing with ionizing radiation. Now, ultraviolet radiation, X-rays and gamma rays are considered ionizing radiation. So what you should be doing is for X-rays either using a lead apron or standing behind a lead-lined screen. Now, secondly, you should be aware of how X-rays can be used to produce a radiograph, an image of bones. So the first thing to note is that this is produced via a negative image. So you've got to say that X-rays cannot pass through the bone because bones are very high density, so they absorb the X-rays. But the X-rays can pass through the soft tissue. So when the X-rays hit the plate will then go from white to black, so you've got the negative image. So the white is pretty much a shadow of where the bones will be because the bones have absorbed the X-rays, so they can't hit the film and turn them black. The next question says, X-rays can also be used to treat cancers. The wavelength of X-rays used to treat cancers is shorter than the wavelength of X-rays used to produce X-ray images. Explain why. So pause the video now, then unpause the video when you want to go through your answer. Right, so it's very important that you are aware of what the link is between wavelength and frequency and energy. So you've got to be aware that the shorter the wavelength, the higher the frequency, because they'll times together to give the same wave speed for an electromagnetic wave. And the higher the frequency, the more energy delivered per second. So the shorter the wavelength, the more energy is transferred every second by the actual X-ray wave. And that's what a wave is. It's a transfer of energy. So the shorter wavelength X-rays transfer more energy every second, so are therefore more likely to kill the cancer cells. The next question says, energy is transferred from the sun to the earth by electromagnetic waves. Infrared and ultraviolet are two types of electromagnetic wave that are emitted by the sun. Compare infrared and ultraviolet waves. So pause the video now, then unpause the video when you want to go through your answer. Right, now the first thing to note is when it says compare, you're going to have to talk about the differences and give actual differences as opposed to saying one is different to the other, say which one's bigger or smaller or whatever. So give actual differences, but also as well give commonalities, give things that are the same between infrared and ultraviolet. So the first thing you can talk about, and I think it's the same for nearly all electromagnetic waves, is talk about wavelength and talk about frequency and then talk about speed. So where do our marks come from? infrared has a longer wavelength than ultraviolet, so their infrared will have a lower frequency than ultraviolet. So therefore infrared transfers less energy every second than ultraviolet. So there are our comparisons between wavelength, energy and frequency, which you should really know for all the different types of electromagnetic waves in the spectrum. But what are the commonalities? Well, they both travel through a vacuum, because all electromagnetic waves travel through a vacuum. They both travel at the same speed through a vacuum, 3 times 10 to the 8 meters per second, the fastest speed in the universe, because they're all electromagnetic waves travel at that speed through a vacuum. They're both transverse waves, because all electromagnetic waves are transverse waves. And finally, they both transfer energy from one place to another, because that is what a progressive wave like an electromagnetic wave will do. So please do remember to identify both the differences between the two types of wave, but also the common features of those two types of wave. So the next question says, ultraviolet radiation is a type of electromagnetic wave. So give 2 properties of all electromagnetic waves. So pause the video now, then unpause the video when you want to go through your answer. So like we said before, it's very important you can state the common features of all electromagnetic waves. So they're all transverse waves, they can all travel through a vacuum, they all travel at the same speed, they all transfer energy, and they all can be reflected, refracted and diffracted as well, because that's what all waves do as they transfer through mediums. The next question says, when light travels from one substance to another, refraction takes place. Figure 1 shows a ray of light travelling in air and reaching the surface of a glass block. So firstly, complete figure 1 to show the direction of the ray of light as it travels through the glass block and emerges into the air. Then secondly, why is light refracted as it travels from air to glass? So pause the video now, then unpause the video when you want to go through your answer. Right, so you've got to be able to draw refraction as it goes through materials. Now the first thing to note is, because the light is going from air to glass, it's going to a denser medium, so it's going to slow down, because light travels slower in the more dense mediums. So to show that, it will actually be refracted towards the normal, because it's slowing down. So you can see in this image that the ray bends towards the normal as it enters the block, but then when it goes back into the air, it's in the less dense medium, so it speeds back up to its original speed in the air before it hit the glass block. So therefore the rays are parallel to what they were before. Now why is the light refracted as it travels from air to glass? Well, it's the idea that the speed of the light will change, because it's going from materials of different density. So it's going from air to glass, which is a more dense material, so therefore it will slow down. So you would say the speed of light decreases as it enters the glass block. Refraction is all due to the angle at which the object hits the new material, and the fact in the new material it is travelling at a different speed. So the next question says, a ray of light passes from air into glass. Figure 9 shows a wavefront diagram for the light. So explain why the light refracts as it passes from air into glass. You should refer to wavefronts in your answer. So pause the video now, then unpause the video when you want to go through your answer. Right, so because this question is worth 3 marks, we're going to have to talk about it in a bit more detail and mention the idea of wavefronts. So like we mentioned before, the light is going to slow down as it enters the glass block. Why is that? Because the glass is more dense than air, so light will slow down in it. Now we're going to have to now refer to our wavefronts. So the idea is that as the air is hitting the glass at an angle, you can see on your diagram that part of the wavefront is travelling at a slower speed than the other part of the wavefront. So at that point, it's going to cause the light to somewhat skid, because one part's travelling slower than another, so it causes it to change direction and to refract. So our 3 marking points are: light slows down as it enters the glass, so each end of the wavefront travels at a different speed, so the wavefront changes direction. Our next question says, X-rays form part of the electromagnetic spectrum. Radiographers use X-rays to produce images of bones inside the body. Explain why X-rays can be used to produce images of the bones inside the body. Now table 2 shows the effect of exposure to different doses of radiation. During an X-ray, a person receives a dose of 0.5 millisieverts. The radiographer takes many X-ray images each day. Explain why the radiographer stands behind a protective screen when taking an X-ray image. So pause the video now, then unpause the video when you want to go through your answer. Right, so again, how does an X-ray produce images of bones inside the body? So X-rays are absorbed by bone because they're high density, but pass through flesh and soft tissue because they're low density, and you get your image formed. Now the second question, why does the radiographer stand behind a protective screen? Well, taking lots of X-rays will give a large dose of radiation because it's a cumulative effect. So that would increase the risk for the radiographer. The higher the dose of ionizing radiation you absorb, the bigger the risk that you would have. So therefore the screen will absorb some of the X-rays, so it reduces the risk to the radiographer. The next question says radio waves form part of the electromagnetic spectrum. Figure 10 shows one use of radio waves. Explain how electrical signals in the transmitter produces a signal in the receiver. So pause the video now, then unpause the video when you want to go through your answer. Right, you've got to be aware of how a transmitter can produce radio waves and how a receiver can receive radio waves. So how does the transmitter work? Well, an electrical current in the transmitter, which is an alternating electrical current, will produce radio waves. The radio waves are then absorbed by the receiver, inducing an alternating current in the receiver. Now, it's important to note that the frequency of the alternating current and the frequency of the radio waves in both the receiver and the transmitter will be the same value. So if your alternating current is at 50 Hz, the radio wave produces at 50 Hz. Whilst if the aerial absorbs a radio wave of 200 kHz, it'll produce an alternating current of 200 kHz. So let's now have a look at some questions on the magnetism and electromagnetism topic for GCSE Combined Science, on the topics that will come up on the 2022 exam paper. So the first question says, a teacher demonstrated how a magnetic field can cause a copper rod to accelerate. The teacher placed a copper rod on two brass rails in a magnetic field. The copper rod was able to move. So the teacher closes the switch and the copper rod accelerates. Explain how Fleming's left-hand rule can be used to predict the direction in which a copper rod will move. So pause the video now, then unpause the video when you want to go through your answer. Right, for this particular question, it's asking you to explain how Fleming's left-hand rule works. So you've got to know what each finger on your left hand and thumb represents in Fleming's left-hand rule. So firstly, you would hold your thumb, your first finger, and your second finger all at right angles to each other, because the three things are at 90 degrees to each other. The second finger represents the current. The first finger represents the magnetic field, in this case pointing downwards, and then the thumb points in the direction of the magnetic force or the acceleration due to that particular force, because a resultant force causes acceleration. So if you align your left hand and have your second finger pointing in the direction of current out of the paper, the first finger representing the magnetic field pointing down from north to south, and the thumb pointing in the direction of the movement, well, therefore the rod is moving from left to right because that's the direction your thumb is pointing in. The next question says, suggest two changes to the equipment that would increase the force on the copper rod. So pause the video now, then unpause the video when you want to go through your answer. Right, for this one, you've got to actually look at the diagram in front of you and also know our equation for the size of the magnetic force. So the magnetic force equation is F is equal to BIL, where B is the magnetic field strength, I is the current, and L is the length of the wire in the field. Now you can't change the length of the copper rod because otherwise we have a different copper rod, but how can you change B, the magnetic field strength? Well, you could use a stronger magnet, that's one answer. Or secondly, how can you increase the current? Well, you would change the resistance on your variable resistor, which is given in the circuit, to increase the current present. The next question says, a teacher demonstrated how the magnetic force on a current carrying conductor in a magnetic field varies with the current. Figure 11 shows some of the equipment used. When there is a current in the conductor, a force acts on the section of the conductor between the magnets. So describe how Fleming's left-hand rule can be used to determine the direction of the force on a current carrying conductor. So pause the video now, then unpause the video to go through your answer. So like we mentioned before, you've got to talk about how you orientate your fingers and then what each finger represents in Fleming's left-hand rule. So you place your thumb, your first finger, and your second finger of your left hand at right angles to each other. Point the first finger in the direction of the magnetic field from north to south, the second finger in the direction of the current, and then finally the thumb shows you the direction of the force. The next question says, The teacher varied the current through the conductor. The teacher determined the force acting on the conductor using the change in the reading on the balance. So describe how the teacher could use the equipment shown in figure 11 to obtain the results during this demonstration. Include in your answer any additional equipment that the teacher would need. So pause the video now, then unpause the video when you want to go through your answer. Right, so it's very important that you can understand how you can work out F, the force. Now, like we mentioned before, we're saying that force is equal to B, the magnetic field strength, times by I times by L. So what you would do is as follows. So you would get your ammeter, your variable resistor, your power switch, your power supply, and your switch. You connect them all in series and you will record the initial reading on the balance. You would then close the switch and then use the variable resistor to change the current, writing down what the value of current is on an ammeter. Again, always stay in any experiment what you're measuring and with what device you're doing it with. You record the new balance reading, then subtract the initial balance reading from the new balance reading and then repeat it for different values of the current, and then you can work out what F is going to be because it can work through like that. Okay, so it will be it allows you to work this out in that particular demonstration. Now the next question says, figure 11 shows a simplified diagram of an electrical motor. Explain why the coil rotates continuously when there is a current in the coil. Then finally explain how the speed at which the coil in the robot vacuum cleaner rotates can be increased. So just basically how can the coil increase its rotation. So pause the video now, then unpause the video when you want to go through your answer. Right, so it's very important you can describe the motor effect. Explain how you can get a coil to rotate in between a permanent magnet. So it's the idea that when a current flows through the coil becomes an electromagnet. So we can say that there's a magnetic field due to the permanent magnet, and the current in the wire causes a magnetic field. Now it's important that because it's a coil, because there's current flowing in opposite directions around the coil, because the coil itself is like a circuit, the forces on each side of the coil will act in opposite directions. Now, why is there a force on each side of the coil? Well, it's because the electromagnet and the permanent magnet will attract or repel each other because they're two magnets next to each other, and so as a result it'll cause it to rotate. You've then also got to remember that in every motor there's something called a split ring. Now the split ring commutator ensures that the coil will fully rotate and that the coil is always rotating in the same direction. Now, how can you cause the coil to rotate faster? So again, if you remember that F is equal to BIL because it's still the motor effect, well, how can we increase the size of F? So you can increase I, which will be increasing the current, or you can increase the magnetic field strength, B, of the motor. Now again, you can't really change L, which is the length of the coil, because the coil is fixed in place already. The next question says, a student clamped a wire between the poles of a permanent magnet. The student investigated how the force on the wire varied with the current in the wire. So the top pump balance was used to determine the force on the wire. So when the switch was closed, the reading on the top pump balance increased. Explain why the increased reading showed there was an upward force on the wire. So pause the video now, then unpause the video when you want to go through your answer. Right, well, it's very important to note that the top pump balance is measuring the force on the permanent magnet. Now, in a bit of revision from Newton's laws, there's the wire and there's the permanent magnet. So when the wire exerts a force on the permanent magnet exerts a force on the wire. Because there's two objects, it's Newton's third law. But the thing is, because it's Newton's third law, they'll exert forces in opposite directions. So if the force on the permanent magnet is acting downwards, and we know it's acting downwards, why is that? Because the reading on the balance increased, so therefore the wire must experience an equal but opposite force on it, which must be upwards, because the force on the magnet is acting downwards. Now you might say, well, why is the balance only measuring the magnet and not the wire? It's because the magnet is the thing touching the balance, the wire is not. The next question says, Table 3 shows the readings on the top pump balance when the switch is open and when the switch is closed. Explain how the values in Table 3 can be used to determine the size of the force on the wire. So pause the video now, then unpause the video when you want to go through your answer. Right, so how can you work out the size of the force? Well, we can also remember that force is equal to mass times by the strength of gravity, which you know to be 9.81. But remember, mass has to be in kilograms. So what you'd do is you'd find the difference in mass between the opened and closed, because that's the actual change due to the magnetic field, because when the switch is open, it's not a magnet. The wire is not a magnet at this point because it's not got a complete current, so it's no longer an electromagnet. So you find the difference between the open and closed mass readings, you convert those into kilograms, and then you multiply it by the gravitational field strength to work out the force. Because again, remember, whilst you can work out the force by doing F equals BIL, you can also work out the force of weight, which is going to be equal to M times by G, the strength of gravity. So I hope you've enjoyed this particular revision session. If you've been successful and you've learned in today's lesson, you should be able to answer GCSE physics examination style questions, assess your understanding on GCSE physics, and understand what topics you need to improve upon for GCSE physics. So thank you very much for watching this revision session on GCSE Paper 2 for Combined Science based on the 2022 examinations. Thanks very much for watching, and have a lovely day.